While talking about Rust, we always mention the borrow checker to be one of the vital aspects. We also saw Rust's borrowing rules, where the second rule states that a reference must always be valid and cannot outlive the data it refers to. We also saw examples of it in our borrowing video. Have you ever wondered how really the Rust compiler ensures that all references are valid and borrowed data does not outlive the owner? The constructs the borrow checker uses for this are called lifetimes. A lifetime is Rust's way of tracking how long a reference is valid. The core idea is that every reference in Rust has a lifetime, but most of the time the compiler infers it automatically. This is how a lifetime is defined. Starts with a tick or single apostrophe followed by a name for this lifetime, denoted by any character. Convention is to write a single lowercase alphabet. Numbers are also valid but not as the first character of the name, and you can use underscore to separate words, like we have in snake case. You only need to write lifetimes explicitly when the compiler can't figure it out on its own. Take this for an example. This longest function accepts two references of string slices, x and y, and returns the longest among the two. So the return type is also a reference, and that is a borrowed value. We know from borrowing rules that the borrowed value can only live as long as the original value. But Rust doesn't know is the return reference coming from x or y. As per the logic in the function, the return value is tied to either of the two inputs. So the question arises that the returned reference is valid as long as which input among the two. Rust refuses to guess. The fix is to explicitly write the lifetime. Here, instead of just writing the string reference type, we can add the lifetime. By convention, I'm just using A as the name for the lifetime. Same for the return type as well. So this means the returned reference will live no longer than both x and y. What this lifetime A actually does is that it tells Rust that x is valid for at least the lifetime A, y is valid for at least the lifetime A, the return value is valid for at most the lifetime A. So effectively, return lifetime lives as long as either of x and y. So understand this thing. Rust is not saying that keep everything alive as long as possible. It is just saying the returned reference cannot outlive either input. So this A ties the lifetimes of the inputs and output together, ensuring the returned reference does not outlive either x or y. Rust compiler actually applies three elision rules. Rule number 1, each reference parameter gets its own lifetime. So whenever there is a reference parameter, it gets its own lifetime, and that is always inferred. Rule number 2, if there's exactly one input lifetime, it's assigned to all outputs. That's why we don't need to write any lifetime for single reference input, because we know as long as this input lives, the reference output will also live. And rule number 3, if one parameter is self or mute self, its lifetime is assigned to all outputs. This means that for types where self is used, like for structs and enums, the output lives as long as that instance of the type lives. So these are the rules where the lifetimes does not need to be written. For all other conditions, we need to write lifetimes explicitly. That's how dangling references does not occur in Rust. Lifetimes appear in different form. Implicit lifetimes, where we don't need to write anything. Explicit lifetimes, where compiler cannot infer, so we need to explicitly write them. The third one is static lifetime. A static lifetime is written like this, and it means that this lives for the entire program duration, which is why we use this only for specific scenarios like string literals, global constants, or maybe even some thread scenarios. Few important things to remember for lifetimes in types like structs, traits, or generics. For example, this struct contains references value. In this case, you must specify lifetimes. Why? Because the struct does not own the data. It just borrows it. The struct cannot outlive name. And while writing the implementation block, you need to use the same lifetime used in the struct. In the method signature for self, we don't need to specify the lifetime because of the third elision rule. For traits, we can write like this, but since it uses self and no other reference can live longer than self, again as per third elision rule, we don't need to write anything. Lifetimes and generics can also work together. Here we are defining both and using them as intended. Here both are compile time parameters. Lifetime is the major reason why Rust is able to achieve compile time memory safety without garbage collector. Lifetimes do not control the memory duration, it just describes the relationships. I agree that this is a confusing concept, so practice passing references between functions and using in compound types. You will encounter more lifetime errors. Try to resolve them. I feel this is the best way to understand this concept. That's all for now. Like this video if you found it useful, and I'll see you in the next one.